punto della speaker for today, which is Peter Belland, who is going to present the SUMMA Consortium.
Hi, thanks everyone for continuing to pay attention this late. This will hopefully be a fairly short talk because unusually I'm presenting work that we haven't done yet, that we are about to start. So this is we have started it earlier this year. This is a new Horizon 2020 project called Scalable Understanding of Multilingual Media, SUMMA for short, or SUMMA if you've got classical education. It's a project in partnership with the BBC, UCL, QCRI in Qatar, Deutsche Welle, the German national broadcaster, IDIAP, Fribourg, Letta in Latvia, and the University of Sheffield. And the motivation for this was work we previously done work on broadcast speech recognition with the BBC, and attending various BBC News Hack events over the last couple of years. We've been talking to various users within the BBC, and in particular BBC monitoring. So I don't know how much you've heard about this part of the BBC, but essentially their job is to monitor TV channels from around the world, with a slight emphasis on I guess, languages where there's parts of the world where there's a particular security need to know more about what's going on in those countries. And the way the setup works is they have 300 journalists all sat in a building near Reading. Each journalist simultaneously monitors 4 television channels in languages they're proficient in, and also online text sources. And this is huge amounts of data that they deal with. So in total they're looking at 250 video channels, which works out at a petabyte per year of streaming data. They've got access to 1,500 TV channels, almost the same amount of radio stations, and just on Arabic satellite channels alone, you're looking at 700 free-to-air channels, increasing at a huge rate. And at the moment, these processes are very, very much manual. People monitor 4 stations because that's all they can manage, and clearly they can't keep up with the scale and the increasing scale of this task. And this is the kind of motivation behind this project. So what we're aiming to do in the project is to improve the whole area of media monitoring by performing a whole series of steps automatically. So we're looking at trying to analyse media streams across a whole range of languages and aggregate them and summarise this streaming content to try and make sense of it. And from this, we want to try and construct knowledge bases, so information about what's going on in that media. And then with that data, supply visualizations that allow humans further down the pipeline to make use of the data and to understand it. So I guess I've really summarised the main use case, which is monitoring of external media, so media coming into the organisation. And the idea behind that is to try and identify, what sudden events are happening in the world that we need to pick up, what people are suddenly featuring in the news that we need to go and understand more about. And the example from this week, an MP is shot. Who is this MP? What do we know about them? What can we find out? There's a sudden need to bring this information together and deliver it to the people who are going to be editing and producing stories further down the line. And in kind of parallel with trends and people, we want to try and look at how ongoing stories, the international stories, the war in Syria, for example, evolve over time. What new steps are happening? And also, there are uses for internal media monitoring. So this is where, particularly with Deutsche Welle, they want to take the media within the organisation and allow them to re-edit it so that it can be rebroadcast in different form and reuse content more efficiently. And also there's an increasing interest in data journalism. So this is the idea of actually using the data and the streams of news coming in to actually identify new stories based actually on the raw data. So there's an example here of what we're hoping to achieve with the complete pipeline. So we might have 3 articles. These could be TV articles, text articles, radio articles, all talking about events in Syria, including a blog post. And the idea is that at the end of the pipeline, we'll be able to identify what's the story, what's the common thread in this, from these news sources. One of which would be Syrian rebels took over Aleppo and Assad gave a speech about the battle. This is a prototype system that we are planning to create as part of the project. I won't go in too much detail here, but you can see the idea of this is to enable a media monitor to monitor the audio-visual content, whilst at the same time having highlighted tags that show what are the key entities in here, and allow them to home in on particular stories. And a second prototype, the idea here is that we can extract entities from these streams, entities of interest to a particular story, and as the streams are essentially moving past, we can flag up when those entities appear in great quantities in various parts of the broadcast. And this is one here example is related to civil war in the Ukraine. And this is an example of how a story would develop, and we're hoping to pull out the key entities here again. So there's a Houthi rebellion in Yemen. We're able to pull out the characters who are associated with this story and map to where they feature in the streams of media. So the overall platform, as you saw, involves a huge number of partners and is a fairly ambitious architecture overall. Just to sort of distill it down for you, first of all, we will be ingesting audio, video, and text. We are going to do speech recognition, then machine translation of that ASR output, segmentation and clustering into speakers. Once we've got that, we can identify what are the named entities, what are the people and places, and what are the links between those based on the data. Once we've got that, we can start to summarize the stories, extract the key points, and also detect the sentiment. What is this, a positive or negative news story? And then finally, once all that's been produced, we can make this visualized so that people working in journalism can actually use this information to enhance their jobs. So there's a huge amount of multilingual technology here. This just summarizes the languages that we're going to be working with, subcategorized into how much resource is already available. So we can see Arabic, English, German, Spanish have got good resources. Portuguese, Russian, and Farsi, there's lots of resources out there, maybe of not such good quality, maybe not so plentiful. And 2 languages we plan to work on that are more limited is Ukrainian and Latvian. And you can see here that we're planning to do speech recognition and machine translation in all those languages, and then entity tagging in most of them, and semantic parsing in a range of these. And where we don't do semantic parsing, where we don't have that capability, we'll be using the translated output. So just to focus, before I finish off on the challenges that are specific to speech processing, the aim here is to produce everything in an online fashion. So this is streaming data coming in. We don't have the luxury of processing it hours after the fact. So the ASR needs to work in an online fashion, and we want to have a very low latency. And we're looking at a target of 30-second latency for the pipeline. Eventually, this is going to be a big challenge. Clearly, we have the challenge of working with under-resourced languages, ones where, for example, very little captioned broadcast data is already available to use for training building systems. We're going to be needing to do online speaker diarization, and if you're sending ASR output to downstream tasks such as entity recognition and translation, it's very important to have punctuation in your output. So we need to make sure that punctuation is handled automatically, and whether that's using a kind of machine translation approach or using prosodic features in the audio, we're working on both of those. And of course, there's opportunity to do quite a bit of nice research over the next couple of years. So we're obviously going to be working quite heavily in cross-lingual ASR. We're planning to build on MLAN, LHOOK, KLHMM, which are all techniques that SUMMA partners have been working on over the last few years. There's also a whole load of work to do around cross-lingual lightly supervised training. So in our recent NST project working on BBC data, we've been doing a lot of lightly supervised training from captions. We're going to have to try and look at applying that in a cross-lingual fashion with perhaps zero well-transcribed resource from those languages. And of course, there's a lot of potential to do factorized adaptations. So looking at how we can share properties of speakers and acoustic environments across languages, and we need to look at factorizing out the effects of those various different factors to make maximum use of the training data. My only technical slide of the talk before we finish, LHOOK actually has been very nicely explained already by Junyang, so I won't go into that. This diagram on the left. On the right is just an example of how the MLAN scheme works for cross-lingual recognition. So the idea here is that you train a neural network in a multitask fashion to share hidden layers between source and target language, and that allows you to extract bottleneck features which are in some way language independent, and you can use those as features to enhance data from your target language. You can train a neural network using those bottleneck features, which we find works very well when you've got limited amounts of data. And that's one more. This is actually a system that we've got running already online now. So what this is just an example of how things are looking. So you can see down the bottom the ASR transcript, and you can see how the entities are being extracted from that, and then the story highlights at the top there are actually being automatically produced from that ASR transcript. So thanks very much. Hopefully I'll update you in the future UKSpeech.